Inheritance is one of the golden features of Java that allow the programmers to achieve code reusability and also helps in reduction of code length. With inheritance, a programmer can extend the functionalities of one class to the other class. To understand, let us create a class 1 containing some variables. Define a function get which modifies the values in x and y. Define a function show that prints those values. Now we need a class that has the same attribute as class 1, with an additional feature to add these values and store them in a variable that belongs to the new class. Let us create a class 2 that extends class 1. You notice the word extends in blue is actually a keyword. Extends allow the programmers to inherit properties from superclass 1 to subclass 2. In the class 2 we create a variable sum. Define a function add x and y and print them. In the main, create an object of the subclass class 2. Send 5 and 6 as parameters. Show and display functions. That's it. Our program is now ready. Let us compile it and see the output. It displays x and y of show function of class 1 and also displays x, y and the sum of the display function of the class 2. We just learned about single inheritance. Let's talk about multi-level inheritance. For that, we create a class 3 that extends class 2. Declare a variable, a function var operate, perform some calculation to store in variable var, and print them. In the main, change the class 2 to 3 and call the function var operate from the object. On building, we see the output of class 1, class 2, and the class 3, which displayed the result of the variable var as 41. This shows that multi-level inheritance is supported by Java. C++ programmers may wonder if Java supports the concept of multiple inheritance. Let us try. We put 1 along with 2 next to class 3, which means 3 should acquire features of both 1 and 2 as in C++. Indication of a red line in NetBeans means an error. It says open flower is expected, which means the syntax is not correct. Let us try multiple inheritance using 2 that extends 1. Displays the same error. This implies multiple inheritance is not supported in Java. However, multiple inheritance is partially achieved using the concept of interface. Let us verify if Java supports cyclical inheritance, which you see in the block diagram. To do that, we write 1 extends 3. The red line shows an error in syntax. Cyclical inheritance involving inheritance tutorial.1. Therefore, we conclude Java does not support cyclical inheritance as well. Moving towards the next topic with basic knowledge about inheritance in Java, let us learn about the keyword super. The keyword super is used to call a method or a variable of the immediate parent class. We will learn how to effectively utilize the keyword super in a program. We create a class first and initialize a variable a with 10. You notice we haven't mentioned any access specifier before the declaration. Since no access specifier has been mentioned, it has been set to default. Next, we create a second class that extends first. Initialize a with 5, b with 5 and c with 10, which are all in default mode. Define a function update and b is equal to super.a. The super a in class second is referring to variable a in class first. We add c is equal to a to see the difference between a and super.a. Call the function display and print the values in the output panel. This is a simple line. Value of a is equal to value of a in superclass is. We can even use super.a directly to print without the need of an extra variable. In the second, we create objects of class second, which is a subclass. We display the values of each variable before and after the update method to see the difference in values. On clicking build, we get the following output. Before the update method, values were the same as they were initialized. B is equal to 5 and C is equal to 10. Value of variables after the update method call have been changed. B is now 10 and C is now 5. If we explicitly mention the access specifier as private, line 34 shows an error. We conclude that the super keyword cannot access the private fields of superclass. If we use protected access specifier, no errors are generated, and on compilation, we get the same output as earlier. Hence, we conclude that protected data members can be accessed by the super keyword. Java allows the use of the keyword super with parameters for parameterized constructors. As usual, we will create a class first, declare 3 variables a, b and c, create a parameterized constructor, print to know when this constructor was invoked, and assign the parameters to the variables. No inheritance can be studied with only one class, so we are compelled to create another class. Class second that extends first. A variable and then a constructor. Super LMN. The purpose of super LMN is that it calls the constructor of its immediate superclass and it makes sure that it is the first statement in the second constructor. Assign O to D. We need to display all values, so we define a show function. Our code is all ready to execute. Create an object of class second and pass parameters, say 1, 5, 3, 4. Call show function and build. If you see carefully, when the objects of class seconds are created, the constructor of class second contains super LMN, which upon execution invokes the constructor of class first and then the constructor of class second is invoked, which explains constructor first being printed before constructor second. Our object.show displays the value using system.out.println, which displays in the output panel. Summary of what we have learned today. This is Prasuntalang. Have a nice day.